Chapter 1, Section 6, Questions 1 and 2. Questions 1 and 2 will be changing from scientific notation to decimal notation. Decimal notation is regular numbers. So, this is a regular number. We're going to change it into scientific notation. The purpose of scientific notation is to take a number that is extremely long and hopefully make it shorter. When you're making it into scientific notation, you want a single non-zero number to be on the left-hand side of the decimal. So the decimal will go here. So we will get 5.807. The rest of these are zeros, so they're going to disappear. And we are going to times. This is one of the two places in algebra that we're going to use an x for multiplication. It's this, and in chapter 4 we're going to use matrices. 10 raised to the, and many students want to count. A decimal point that's not in sight is always, always on the right. We're going to count from the original decimal to the new decimal point, and we're going to count 1, 2, 3, 4, 5, 6, 7, 8, 9. It moved 9 places. It was a very large number, so this is positive. Some people do not have to count all of those. They can look at the commas and say 3, 6, 9, done. All right. Here, we want to express this in decimal notation. This is a negative, which means that this number is going to be a small decimal number, and we're going to move it over 3 spaces in a way that's going to make it smaller. So 1, 2, 3. This is where the decimal will end up, and these empty little pockets will end up with zeros in there. So the answer is 0.03201. It is polite to put a 0 in the front for our college professors. Now, the important thing is if you're going to put these little counting troops in here, do not have that on your final answer. Because I and other math teachers have said that if you put the little troops there underneath, that we're not going to decide which of those actually represents your decimal point and which of these is just a part of your little egg cup things. So please make sure that if you show this work, which is totally fine, many teachers teach it this way, please leave that as work and have your answer beautifully written without the little things underneath it. Chapter 1, Section 6, Questions 3 and 4. You will be multiplying and dividing with scientific notation. As you're loving the evil math teachers, we are not going to make this easy on you, because if you take as an estimate 3 times 5, you will get 15. That's 2 numbers in front of the decimal. That's not scientific notation. We are setting you up to get you confused. We have to do 3.2 times 5.7. And what we found is that some students have forgotten how to multiply 3.2 times 5.7. So let's go over that. 7 times 2 is 14, carry the 1. 7 times 3 is 21, plus 1 is 22. Moving on, we have a 0 here. 5 times 2 is 10. I'm going to use that as my carried 1. 5 times 3 is 15, plus 1 is 16. And then we add this, we get 4, 2, 8, 1, 1, 2 decimals in the question, 1, 2 decimals in the answer. This is 18.24. My estimate was about 15. It's bigger than 3, it's bigger than 5, it's almost 6, which is why it came out as 18.24 times 10 to the, it says to multiply, but you really add 3 plus negative 8 is negative 5. This is the answer to the question, but it's not in scientific notation and it's not in decimal notation. I'm going to ask you for the decimal notation first, which means that I'm going to take this and I'm going to move it over 1, 2, 3, 4, 5 places. So our decimal notation answer, which is our regular numbers, a 0 in front of the decimal point is polite. There were 3 zeros and then 1824. Then our scientific notation answer, we know that the decimal is supposed to go here after the first number that is not a 0, so 1.824. Now, if you start drawing things under here, it's going to be in the answer, and that's bad. So if you need to, go back over here and count 1, 2, 3, 4 places. It's going to be times 10 to the 4th. This is a very small number. It's still positive, but it's less than 1. That makes it a -4. Any of these that have the little zeros in the front of it, the decimals in the front, are going to have a negative exponent. And if it has a positive exponent, then the decimal is going to go the other way and make it into a larger number. Here we're dividing. We're never going to divide when the denominator is a decimal. So if we have 5.4 divided by 1.2, I'm going to multiply top and bottom by 10. You're going to remember that we're going to keep doing this in chapter 1 and chapter 2. All the times we have to do fractions. Really important in chapter 6, which is all fractions all the time. We're going to get 54 divided by 12. You might make your life a little bit easier if you notice that we can divide those numbers by 2, in which case 27 over 6. We might make our lives easier if we notice that we can divide both of those numbers by 3, in which case we would get 9 over 2. And you might know that 9 divided by 2 is 4.5. But let's say that we didn't actually notice that this is going to become 4.5, and we're going to take 54 divided by 12. 12 goes into 54 4 times without going over. 4 times 12, here is 4 times 12, is going to give us 48. There's a reason that I'm doing this on the side. Part of it is to remind me that I'm multiplying 4 times 12. It's to help my brain remember that this is what I'm multiplying to get this number. But it's also to support you in chapter 5 when we're going to be doing long division with polynomials. I'm going to use a different color to subtract because that's the same skill I'm going to be using in chapter 5. Oh, we're going to have to borrow. 14 minus 8 gives us 6. Now, we're going to have to keep going with decimals, so I'm going to put a decimal here and it's going to come straight up. I'm going to put a 0 here, which will drop down. 12 into 60 goes in there 5 times. I'm thinking about 5 times 12, which will give me 60. I'm going to subtract, and I really want to get the 0 at the end that says I can stop because 4.5 is the answer, and 4.5 is the answer. So here, dividing this will give me 4.5. It says divide, so we really subtract. Be very careful. A lot of people accidentally say that the answer is 6 because they see that this minus. But if you're subtracting, what you're really thinking is 10 to the 8th subtract -2. So minusing a negative makes it positive, so you actually get 4.5 times 10 to the 10th power. That is actually scientific notation. It will not always come out as scientific notation. So we need to find our decimal notation. We may need to have little swoopy things underneath, or we can count that it's gone over one place, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, appropriate commas are appreciated on large numbers like this. And we start counting from the right, 1, 2, 3, comma, 1, 2, 3, comma, 1, 2, 3, comma, and we get hundreds, thousands, millions. We have 45 billion here. And then scientific notation, we have 4.5 times 10 to the 10th power. Chapter 1, Section 6, Question 5. Word problems with really big numbers. So find the answer in decimal notation, then write it in scientific notation. Use dimensional analysis and label. So we start off with 4.3 milligrams. There are a number of ways to do this. If you know that milligrams, that there are 1,000 milligrams in 1 gram, and then many students know that there are 1,000 grams in 1 kilogram. This is dimensional analysis. This is very important in your science classes. We want the milligrams that are on the top to cancel out with the milligrams on the bottom. Grams on top, cancel out with grams on the bottom. We started off with milligrams and then we slowly changed it into kilograms. And so the answer is 4.3 times 10 to the, we divided it by 3 zeros and 3 zeros, it's going to have -6 kilograms. Now, be careful, this is in scientific notation. We're going to have to find the decimal notation answer. Interesting thing with very small numbers. I can put 6 zeros here and then write the 4-3. That is one way of doing 4.3 times 10 to the -6. If we were to count from here, 1, 2, 3, 4, 5, 6, and it works out. That is another reason why the college professors like this 0 in the front. And then kilograms. Make sure you label it. Scientific notation, 4.3 times 10 to the -6 kilograms. From our college prep science teachers, I have heard that you can also use King Henry died by drinking chocolate milk. King Henry died by drinking chocolate milk helps you remember kilo, hecto, deca, the base unit, which in this case is grams, deci, centi, and milli. So if you're going from milligrams to kilograms, you're going to count from here over 1, 2, 3, 4, 5, 6. So we're going to take the 4.3 and count 1, 2, 3, 4, 5, 6. We'll get the exact same answer. So if you do that, show me, I guess, 4.3, that it went 1, 2, 3, 4, 5, 6. Fill in all these like a little egg carton. So that would be it. Probably write King Henry died by drinking chocolate milk up there. You can get the answer very quickly. This will only work on this problem because it is about metrics and we're multiplying and dividing by tens. Here, the distance from the Earth to the Moon is this many miles. You might want to put, in addition to your label, a 1 in the denominator to make sure it stays in the numerator. Miss Jordan drives 7 miles to work each day. So we're going to find out how many trips to work would equal 1 trip to the moon. 7 miles, so this is miles on the top, so miles would be on the bottom, is 1 trip. So in the parentheses is a fact, and it has to be a very common fact. So we were just told 7 miles is 1 trip, 7 miles is 1 trip. These will cancel out, and we will get this number divided by that number. 2, 3, 8, 9, 0, 3 divided by 7 is 3, 4, 1, 2, 9. It is appropriate to do commas. 1, 2, 3, comma. And the only label left is trip. In this case, probably trips for our English teachers. This is our decimal notation. And make sure that you label them both. Appropriate commas are good. And then our scientific notation. The decimal would have to go after the first number. We get 3.4129 times 10 to the, it moved over 4 places, 4. It is a large number, larger than 1, so positive, and then trips. Convert 16 weeks into seconds. This is a very long problem. We're going to start off with 16 weeks. I'm going to put it over 1. Some facts. I know that 1 week, maybe I'll do WK. 1 week is equal to 7 days. I know that 1 day is equal to 24 hours. I know that 1 hour is equal to 60 minutes. And I know that 1 minute is equal to 60 seconds. Now I asked one of the professors whether or not you were allowed to say that 1 hour was equal to 3,600 seconds, and they said no. So keep it broken up into small, useful numbers. And then you'll notice that all of the numbers are 1, so we're just going to multiply the numerator 16 times 7 times 24 times 60 times 60, and we will get a very large number. 9, 6, 7, 6, 8, 0, 0. The only label that is left on this problem is seconds, which is what we were going for in the first place. So our decimal notation 9, 6, 7, 6, 8, 0, 0, 1, 2, 3, comma, 1, 2, 3, comma, seconds. And then scientific notation. Decimal goes after the first number. We get 9.67768 times 10 to the 3, 6, 6. Positive 6 because larger than 1 seconds. Make sure you label them both.